So in the definition of integral, we said that this integration as area finding. Suppose we have a velocity time graph of an object, and the velocity time graph looks something like this. So something like this. And in velocity time graph, we already studied in our 9th standard that area of velocity time graph is equal to displacement. And the velocity, this is time, means this velocity is actually a function of time. This velocity is a function of time. So we are not interested, suppose we are not interested in the overall displacement of the object. Suppose we want to find out the displacement of the object between, so displacement of the object between second and third second. That means the object second it is here, the velocity of the object is here, and in the third second the object is here. So since this is a velocity time graph and the area of the graph is the displacement, but we would like to find the displacement of the object between the second and the third second. So you don't have to find the area of the entire graph, but we are supposed to find the area of the graph in this region, area of the graph in this region. So here, in order to find the area of this, what are we supposed to do? What are we supposed to do? Two things. You are going to instruct the integration that find the area only between these two. So the lower value is 2 second and the upper value is 3 second. Then the velocity, since it's a velocity time graph, velocity is a function of time. Let us say that the velocity is equal to and 3t square minus 1. And if the velocity of an object is 3t square minus 1, which is a function of t, and you would like to find the displacement between the second and the third second. So in order to do that, the same integration will take this form. So in the displacement of the object is equal to integral of velocity into dt, because we know that velocity is equal to ds by dt, displacement by time taken, and displacement is equal to velocity into dt, and the velocity is displacement is velocity into dt means 3t square minus 1 into dt, and the total displacement is equal to the total of 3t square minus 1 into t, that is integral 3t square minus 1 into dt. But we want to find the displacement between what to what, second to third second. So in that case, it is integral 2 to 3, I mean lower limit to upper, this is called lower limit, this is called upper limit, lower limit 2 to upper limit 3t square minus 1. Then the usual integration works. So integral 3t square dt minus integral 1 times dt. Here also limit 2 to 3, here also limit 2 to 3. You can do it as one, you can also do it in one shot. So 3t square is 3 times, t square is t power 2 plus 1 divided by 2 plus 1. We have done it so many times right now. Minus 1 is there. 1 means nothing is there. So t power 0 can be taken as 1. So it is t power minus t power 0 plus 1 divided by 0 plus 1. So generally integral x power 0 dx is equal to integral x power 0 is 1, anything power 0 is 1. So integral dx is always x. So here it is t power 0, this thing, the lower limit 2 has to be put here, upper limit has to be put here. So integral 3 t power 2 plus 1 is 3t cube by 2 plus 1 is 3. So usually t square dt is t cube by 3, and minus t power 0 plus 1 is t by 1. So that is what, t power 0 dt or 1 dt or integral dt. Integral dt is t. So t. So it is 2 to 3 seconds, like that we are supposed to do. Now usually what do we do with this lower limit and upper limit? So what are we supposed to do is, suppose this is a scale and this is 0, 1, 2, 3, 4, 5, 6. Suppose one insect moves from this first mark, the 1 centimeter mark, to 4 centimeter mark. Then what is the distance moved? We do that. The distance moved is equal to, this is 4 centimeter mark, this is 1 centimeter. So this distance is 4 minus 1. So we usually subtract the upper limit minus lower limit. In the same way, in this value, we are saying that integral, this t, 3 and 3 will be cancelled. So it is t cube minus t, and here it is lower limit. So let me use this. Lower limit is 2, upper limit is 3. So t cube minus t. First, in place of the variable, the thing with respect to which we integrated is t. So the t, wherever t appears, first you have to substitute the upper limit and then you have to minus the lower limit. So it will be like this. So first, in place of t you substitute 3. So it is 3 cube minus t, it is 3. So it is 3. The whole thing we have to put minus integral. In place of t now substitute 2. It is 2 cube minus then 2 minus, in place of t we are substituting t. So it is 2, like this. So 3 cube is actually 3 into 3 9, 9 into 3 27, minus 3 minus 8 minus 2. So 27 minus 3 is 24, minus 8 minus 2 is 6, that is equal to 18. So this is how we substitute limits, which is lower limit and upper limit. Based on that, we find some definite value for the displacement or any other thing. So the finding the definite value for a particular interval is what we call definite integrals.